Hello friends, welcome back to the bench. Now, in an effort of modifying our preheater, we built this mocked version on ESP32 of the controller using a thermistor as a thermal feedback. It's not very important what thermal feedback we use at the moment, but the main effort was around how to stabilize the temperature. Right? So initially, when we build it just to turn on and off, including some maybe hysteresis, the temperature was not stable. The temperature would climb too high, and that was pretty much it. My modification that I made, that I told you guys about, I never showed it to you, but I did test it. So first I modified it so it doesn't just turn on the heater, it just sends pulses to the heater. And the on time and off time varies depending on how close to the threshold we are. Although that definitely improved the outcome, right, how stable the temperature is, I missed one very important fact, which this device actually accounts for. So what we need to consider is how quickly the temperature rises. That is the key, not only how close we are. Because if it rises quickly, we need to push less energy into the heater. If it rises slowly, well, then we just wait, right? So let me show you this controller. So this is the one I told you about. The model is REX-C100. It costs $15, well, less than $17 with shipping. It comes with a K-type thermocouple. That looks like this. And with a solid state relay, which is basically a transductor, or at least that's how I think it works. I'm not sure. Let's see it under the scope. I didn't actually learn how to even set the temperature or anything like that, because as I turn it on, it is set to 100 degrees, which works for my test. It is supplied with 230, up to 230, 120 in my case, volts AC. As you can see, output is now on, which is also indicated by the LED on the solid state relay. Now, as you can see, our temperature is roughly 28 degrees. This is roughly correct. We don't need to be as accurate, meaning 1, 2, maybe even 3 degree difference between the actual temperature and set temperature is not a huge deal. But now observe our output as I start heating it to 220 degrees. We are set to 100 degrees right now. It rises quickly, and output turned off at 50. Right? Because it's rising quickly. Now it turned on again and turned off. See, now it turned off. So I was expecting that this would be a very simple controller, just turn on at some temperature, turn off at the other temperature. That's not the case. This is actually a lot more sophisticated than I expected, especially for this price. And I know what you're going to say. It's, I'm easily impressed. Well, consider that this is $17 that you paid for this, right? Would you expect it to be this sophisticated? I did not. So now, I haven't actually tested it, but I did wire everything together, ready to be connected. So I just need to connect the power to this, place the thermistor on the board, and see how well does it stabilize the temperature. So let's connect it. There is a little bit of safety precautions that I took, meaning the hot wires are insulated almost everywhere, so I probably won't get electrocuted working with this, but some electrocution is expected, or at least allowed. So let's get our thermal camera and observe the actual temperature. How well does it work with this heater? Now compare this to the original circuit that was provided by the manufacturer of this preheater to what we have now. A microcontroller, I never actually checked what this is. It a transistor or yeah, I don't recognize it, but it's likely not a it's likely not a transistor. It's a thyristor, most likely. And you know, controlled by the microcontroller. I don't know, why wouldn't you just, instead of working on this, just get one of these? I'm sure the Chinese manufacturer can get these a lot cheaper. If I can get them below 20 bucks, paying how much? That was $70-80 for the preheater. I'm sure if they replace this with this, it would be easier to assemble and much more reliable. But, well, it is what it is. Now, let's get our thermal imager placed somewhere here. Okay. Now, all we have to do is just place the thermocouple in a way that it always touches the board. And now, oh, you see the thermocouple moved. Yeah, we don't want that, but this is the first test. And the heater should start heating now. Yeah, we can see that the heater is heating. Output is on. Temperature has no reaction at the moment, because it'll take a second before first for the heater to heat up and then to transfer the heat to the board. So far our temperatures look good. I got 34, 35 on the thermal camera and the device says 34. Now we're off by a lot. So the board is at 57 degrees now, and we only have 35 degrees on the thermocouple. Now this is to be expected because the couple itself needs to heat up as well. It does have some thermal mass and it is designed to be screwed into a heatsink or some kind of metal or something like that. So we do need to account for that when setting the temperature, because the actual temperature will always be slightly higher than the one registered on the sensor. We are at 37, 38. Okay, at this point the flux on the board is starting to smoke. So we are a bit too high. Looks like 210. Oh, right, because we got low region. 210 is the highest temperature. We had 329 on the heater. It's a bit much. while we have 75 on the thermocouple. So now let's see if we can figure out how to set the temperature. And as you can see now, as it's getting closer, it started reducing the temperature. We are too hot. 338 degrees on the heater is a bit too much. Now we could measure the temperature on the heater instead of the board. But you can see as it's getting closer, it's now started flushing. There is going to be a fair amount of delay before the actual board heats up. Now the smoking is not horrible because there was flux on it, but we have 200 degrees on the board. I can hear something crackling. Probably the board is overheated now. We are at 90 degrees. I need to learn how to reduce the temperature. So we are roughly 120 degrees off, 130 degrees off. It is way overheated, but the temperature of the thermocouple is pretty stable. Can you hear those crackings? That's the sign of overheating. Not to mention the smoke. Our capacitors might explode. Well, we are at 99. And we have 100. Now it's just blinking. Trying to stabilize the temperature. And the temperature is pretty stable. I'm pretty sure I could remove the components now, because the board is way overheated. Yeah, I can just freely start removing the components of the board. Not the capacitors though, they don't want to melt. I like diodes, everything. Now we're at 103, 104. So the heater still blinks from time to time. See that? That's not ideal, because we're already above 5 degrees above. I would prefer not to go 5 degrees above. Maybe 2 degrees above, not more than that. We can pretty much strip the entire board of components because it's so hot. Now we're at 107. That is concerning. Why does it keep pushing energy if we're 7 degrees above? 8 degrees above. And the heater is not turning on anymore. Okay, 8 degrees above. Oh, now it flashed again. Why would it? And it's flashing again. That is a little concerning. I dropped it a 1 degree. The temperature of the heater went down to 278. This was to be expected because there's a big delay between when the heater reaches the highest temperature and the board starts heating. This is something that I would account for in my coding to just slowly start the heater, or to just control it throughout the process, not just turn it on and wait for it to heat up to 50%. Now we drop to 104. So the heater is turning on a little more often for a little longer periods. So right now we are about 90 degrees above the temperature that we read. As I said, this was to be expected because the thermocouple will never make a perfect connection with the board. And this is something that we just need to account for. Maybe if I held it like this, yeah, it works a lot better when it's held like this, but it's burning my fingers, so I can't really hold it for that long. But yeah, this is how it should stand. So what we need to do is just create a nice little holder for it. I'm gonna look around in my junk to see, or in my junk drawer, sorry, to see if I can find something that will hold it in this position. It's a lot better in this position. The temperature is rising nicely. Yeah, so now let's turn off the heater. That also answers our question, how hot can this heater actually get? And it appears that it can go up to almost 400 degrees. Alright, as this cools down, we are at 97, 96 degrees right now, or at least that's what the thermocouple seems to think. Now if we put the thermocouple over there underneath, so this is the problem that we absolutely expected and anticipated. The thermocouple doesn't have a good connection with the board, so we're reading temperature close to the board, not the temperature of the board. So this is the problem we need to solve. Now it's lighting up alarm. There is no pin implemented for the alarm, not in this version, but well, at least we can see the LED alarm being lit up, that we're way above the set temperature, right? So our output is low, but still our temperature is way too high. So if we kept the thermocouple underneath, that would set the temperature of the heater. But again, that's not necessarily what we want. We do want to measure the temperature of the board. So we're gonna have to think about how to solve that problem. We are at 172 degrees. Okay, so far I say this is a perfect replacement for this. It seems to work really well. It seems to be a lot more intelligent than I anticipated. It's easy to set up, easy to connect. There's 6 wires that you just have to wire up, and that's pretty much it. And you need a heater, obviously. Okay, I hope you enjoyed this short presentation. This is the first time I'm using this. I don't even know how to set the temperature, so I need to read through the documentation, which I expected that this is going to be intuitive. So usually the documentation goes into trash right away, but this doesn't seem to be intuitive. So I need to look into the documentation. But it looks like this is going to replace the other controller really nicely, which will allow me to keep the stable temperature of the board for the socket replacements. Until then, I need to just learn how to actually use this baby. But I'm very happy with the results so far. Both how quickly the temperature is read and how the controller reacts to the temperature changes. A lot better than I expected, especially for the price of $17. It's amazing. That's gonna be our mod. Everything got pretty hot because the heater got to almost 400 degrees, but that's good. That's all good. And as you can see, we can just remove the components of the board, heating it up like this. Alrighty, we're gonna stop here. The second part, or whatever part this is, I think this is like part number 3 or 4 of the modding this preheater. And in the next part, we're probably gonna attempt at least a removal of the socket. But for that, there's few more modifications that I have to do to this to actually allow that. Until then, thank you guys very much for watching. I do appreciate you, and I shall see you in the next one.